Have you ever wondered if there's a connection between the harmonious beauty of music and the structured logic of mathematics? Welcome, dear friends. Today we delve into this fascinating intersection where numbers meet notes and equations echo in symphony. Imagine mathematics as a grand orchestra. Each number, each formula, each theorem plays its part like an instrument in a symphony. When they come together, they create the most intricate and harmonious melodies. This is the concept we're exploring today. Mathematics as a music of reason. So what does this mean? In its simplest form, it means that mathematics, like music, is a universal language. It's a language that transcends borders, cultures, and even time itself. The ancient Greeks understood this concept well. The great philosopher Pythagoras once said, "There is geometry in the humming of the strings, there is music in the spacing of the spheres." This is not just a poetic statement, it's a mathematical truth. Take the Fibonacci sequence, for instance. It's a series of numbers in which each number is the sum of the two preceding ones. Often we can find this sequence in nature, in the arrangement of petals on a flower or the spirals of a pine cone. But did you know that this sequence also appears in music? In the scales and harmonies, in the rhythm and melody, the Fibonacci sequence is there, playing its part in the orchestra of sound. Now consider the concept of octaves in music. An octave is a series of 8 notes, with the first and last note being the same, but at a higher or lower pitch. This concept is eerily similar to the number line in mathematics, where we have a set of numbers, and the cycle repeats after every 8 numbers. These examples show us that the relationship between music and mathematics is not coincidental. It's a fundamental connection that exists at the very core of these two fields. Mathematics is a music of reason, a symphony of logic and numbers. It's a language that speaks to us not in words, but in the universal codes of numbers and equations. The Nobel laureate Albert Einstein, a keen violinist himself, beautifully captured this sentiment when he said, "Pure mathematics is, in its way, the poetry of logical ideas." Like a well-composed song, a beautifully crafted mathematical theorem can stir emotions, inspire awe, and make us appreciate the beauty inherent in our universe. As we conclude, let's remember that mathematics isn't just about solving equations or crunching numbers. It's a universal language, a music of reason that resonates with the rhythm of the universe. It's in the spirals of a galaxy, in the petals of a blooming flower, and in the harmonious notes of a beautiful symphony. Today, we've explored how mathematics and music intertwine, creating a symphony of reason. We've seen how the Fibonacci sequence plays its part in the orchestra of sound, and how the concept of octaves mirrors the number line in mathematics. And we've realized that mathematics in its purest form is indeed a music of reason. So next time you listen to a piece of music, remember you're not just hearing notes and melodies, you're listening to the symphony of the universe, the music of reason, the sweet sound of mathematics. Thank you for joining us on this fascinating journey. Until next time, keep exploring, keep questioning, and keep appreciating the beautiful symphony of mathematics.